But still, it is important that you join the class on time. Okay, no?
Sir, we were doing light shadow reflection, right?
Yeah, actually, in that class, no, since you were the only student who was present, so we did started with that chapter. Okay, and in the previous class, you were absent, I think. Were you present, Halima, in the previous class?
Sir,
I think no, you were absent.
class I was present.
You were present.
Yeah.
Okay, okay. See, for just half
Sir,
an hour, we did.
sir, I wasn't present. I was absent.
Yeah, that's why I was saying no, in the beginning, like you were absent actually.
Yeah.
Yeah. So, like we kind of had a backup class, like kind of extra class for you. Okay, no? Since you were the only one present in the class, so thereby we did discuss some concept from the light, as it is going to be there in your half yearly exam. But in the batch,
Yes.
we had started this chapter getting to know plants. Okay, now. So just let me get a
Sir,
confirmation
right now
from.
also I am the only one person, right?
Yeah, today also. So that's why I will be just getting a confirmation from others. Okay, now whether they will be joining the class or not. Okay, if not, then we in today's class we can continue with the chapter light. Okay, now.
Hmm.
So just one more, will others be joining? Let me get a confirmation. Okay, once I get to know from that, then I will be continuing. Okay. By the way,
Sir, also it is 8:46. Still they didn't join, right?
I think
So I think
it's time that
they won't
I
be
think
joining.
I think so. So let us start this chapter. So in the previous class, no, we did learn about light. Okay, and there was few basic things which we learned about light, right? We learned that light is a form of energy which
That what is light and
right,
yeah, we will learn.
and we did learn that light is a form of energy which gives us the which enables us to see different things around us.
Yes.
And sun is the ultimate source of
Sun is,
energy in the
yes.
right.
Solar.
So it's
Yeah.
in the solar system, it's the ultimate source of energy for the planet Earth. Right now.
Sir, and yes, sir. And also, sir, 1 minute.
Yes.
Sir, light is also reflected. The light can also be reflected.
Yeah, of course,
Sir,
light.
and, sir, and also light is the fastest source. Like, yeah.
Okay. See, first of all, we did learn about light. So we learned that light is a form of energy. It is an electromagnetic wave that travels in a straight line, and it does
Yes.
not requires any medium to travel. It does not
Yes.
require any medium. Like light is coming all the way from the sun to the earth. Is there any
Yeah.
medium between the sun and the earth? It's
No, sir.
vacuum basically. So
Yeah.
vacuum is emptiness. There isn't anything in the vacuum right now. So light
Yeah.
does not require a medium. It can travel even in a vacuum. So we did learn basic things about the light.
Sir, like the properties of
What
light,
happened to
like
this?
light travels
Yeah.
in a straight line, and
First,
light travels faster than sound.
exactly. So it's a form of energy. That is one thing which we learned. Travels in a straight line. Hmm.
Last class I had a doubt, right?
Yeah, sure. Let me know.
Sir, why can't we see a book which is placed behind a wooden screen?
Why can't we see?
Why can't we see a book which is placed behind a wooden screen?
Okay, because the light will not be falling on that book now. All the light has been obstructed due to the wooden screen. For book or for anything to be visible, it is important that light falls on it and light reflects from it. Only then it will be visible. Now the setup is kind of like this. As what I have understood, there's a wooden block like this. Okay.
Yes.
And behind this, you have placed a book.
Yeah.
Behind this, you have placed a book like this. And here, there's a source of light. Let's say there's a candle or there's a bulb.
So
You're saying,
I
why
think,
can't we
sir,
see?
sir, you are saying that I think so that the wooden screen is already opaque, so the light always reflects, right?
Hmm. So see, this wooden object being opaque in nature, it will not allow the light to pass through it. It will reflect the light. The light rays will bounce back from the surface of the wooden block, wooden object over here. So
Yeah.
since light is not falling on this now, so thereby it will not be visible. And in fact, a shadow of the wooden block will be formed over it. What will happen? A shadow will be formed now, because we know that whenever the path of light is obstructed, shadow is formed. Whenever the path of light is obstructed, shadow is formed. Getting it? Getting it now? Okay. Okay. By the way, for students who will be watching the recording of this chapter, see, in the batch, getting to know plants is going on. But since only Halima, you are present in today's class, thereby we are kind of having a backup class for you. Okay, now?
Yes.
So that other students don't get confused like which chapter is going on in the batch. In the batch, getting to know plant is going on. But as only Halima is present, thereby we are doing the chapter light. Okay. Okay. And for others, while we get to the chapter light, there will be continuing with that chapter also. So you won't be missing that chapter for others. Okay.
Yeah.
So it's a form of energy. It travels in a straight line, and it is an electromagnetic wave also. So it is a
Yes.
electromagnetic wave. Talking about its speed, we did learn that it has a speed about 3 lakh kilometer per second. So
Per
in
second.
just 1 second, light travels a distance of about 3 lakh kilometer. Getting it? So how fascinating this thing is, right? Okay, and light casts shadow also.
Yeah.
Light casts shadow. As we have learned over here, this shadow is casted. So what is the condition required for shadow formation? There has to be a source of light, right? There has to be an
Yeah.
opaque object and a screen on which the shadow will be formed. So light casts shadow also. Okay.
Yes.
Furthermore, light requires no medium. Light requires
No medium.
no medium. And if we were to talk about in which when the light will be maximum, when the speed of the light will be maximum, when it will be traveling in the vacuum. Okay, no? So speed of light is maximum in vacuum. So keep that thing in mind. Okay. Now another thing is that, by the way, have a look at these images also. Can you guess what are these images? Halima, by the way, turn your camera on in the class. What are these images? Can you guess?
Sir, these images are of a light.
No. See,
Uh,
in the universe, there are certain luminous bodies. Like we have stars. Stars are the luminous body,
oh,
right?
luminous and non-luminous.
Yeah. See, these are the black holes. Have you heard
Oh,
of this term before?
yes.
Okay, now this is believed to be the image of a black hole. This is the image of a black hole as it is visualized in movies. And this was the actual image of a black hole recently taken, I think, by the James Webb Telescope, I believe. Right now. So
Sir,
apart
but then
from the
this is
yes,
a bit blur.
yeah, it is bit blur. Okay, now. So it's not. It wasn't very much sharp. It's bit blurry. Okay, now. Anyways, we also have learned in the previous classes that on the basis of whether an object emits light or not, there are two kind of objects: luminous objects, and then we have non-luminous objects.
Non-luminous.
Right now.
Sir,
So
non-luminous
stars,
objects are that does not produce visible light or deflect or allow light to pass through.
right? Okay. Like if you were to talk about the black hole, so the question is black hole a luminous object or non-luminous
Sir,
object?
it is a non-luminous object, I guess. Sir,
Okay.
because I
Yes, Salima?
Sir, because black hole is not, I mean, it is a non-luminous object because I think it reflects light.
See, the thing is now, talking about black holes, talking about the black holes now, see, the black hole in itself is non-luminous, but the region surrounding the black hole is luminous. See, this
Oh,
middle zone that you see, that is actually the black hole. That is actually black hole. But this all region that is this region that is surrounding the black hole, that is luminous. So the region surrounding a black hole will be highly luminous. Okay, you getting it? The region
yes,
surrounding the black hole, that is highly luminous, but the black hole in itself is not luminous. It's a non-luminous object. Okay, now. So I thought
yes.
that would be interesting to understand. Okay. The properties of the light we have learned already in the beginning. Okay.
Sir, can I say more properties of light?
Yeah, sure.
Sir, we see things because it reflects into our eyes.
Hmm. Good.
Shadows are formed when light is blocked by an object.
Very good.
When light is incident upon an object, some
Hmm.
are absorbed and some are reflected.
Good.
Light travels in a straight line and light travels faster than sound.
Very good. Very good. Okay. Now, apart from all other, this one, another important thing is that whenever light will be falling on a surface, out of these three falling things can happen.
What, sir? Can you repeat?
I was saying that whenever light will be falling on a given surface now, either the
Yeah.
light might be reflected, might go through refraction, or might be absorbed by the surface. Okay, now.
Okay.
So when light falls on an object, it might go through following. So either it might go through reflection,
It might go to reflection or
go
it will
through
absorb.
refraction, and then absorb. Okay.
Reflection,
Not
refraction, and absorb.
now, in order to understand these, have a look at these images, for example. See, see, like how are we able to see the things around us? How are we able to see the things around us? So, like the sun's rays are falling on this rose, and the rays are reflected back from the surface of the rose, and those reflected rays enters in our eyes, and hence we're able to see what is basically happening. The sun's rays are falling onto this. Okay.
Yeah.
And as they fall on it, so these light rays get reflected from it,
Yeah.
and these reflected rays reaches our eyes. So as it reaches
Yes.
our eyes, then we are able to see it. Right now, that's how we are able to see the different objects. So here, reflection of light rays has taken place, right? So it is due to
Yes.
reflection that we are able to see different things around us. Okay. Furthermore, talking
Sir,
about
so
hmm,
light is reflected from it into our eyes, which
hmm,
enables us to see, right?
which enables us to see right now.
Yeah.
Okay. Furthermore,
So like light
mhm,
from a source like sun falls on the object. The object
yes,
reflects light in all
hmm,
possible directions.
hmm, hmm,
The reflected light from the object reaches us eyes. Our brain
hmm.
receives the information from the eye, making us to see the object.
Exactly. So what they basically happens if you were to talk about eye. The structure of the eye is such that at the back of the eye we have a structure called as retina. Okay.
Yeah.
So see, this is your eye for this is our eye, for example. So there's a structure on our eye called as retina. So first of all, the image of the first of all, the light rays that falls in our eyes now, it will first of all pass through the eye lenses, and it will kind of meet at a point, right? It will meet at a point. Okay, so the light rays
Yes.
will meet at a point. Now from that point, the information will be sent to our brain. The information will be sent to our brain.
Brain.
So information will be sent to our brain in the form of electrical signals. In the form of electrical signals, the information is formed. So this retina is not
Sir,
like a plain mirror. It's a different thing. It's a
sir, what do
alive
you mean
tissue.
by
Hmm.
electrical signals?
Electrical signals, see, like it's not like when you see the formation of image in a plane mirror. So there is it
Yeah.
so that the we get to see in a plane mirror the way how image formation takes place in a plane mirror and in our eye, both of them are different. Both of them are different. So what is happening? The image, the light rays that are combining at this point on the retina, it will be first
Yeah.
of all the information of the image formation in the form of electrical signals will be sent to the brain. Okay, now so thereby what will the brain will do, the brain will interpret those electrical signals, and then image formation will be taking place. The if the
Yes.
this the I mean to say, the information is being sent to your brain in the form of some electrical signals. They are nerve cells in our
Yes.
brain that will be receiving these electrical signals, and the brain will
And
process the image, it will interpret
yeah.
it, and then will interpret it as the actual image of this rose. Okay, now so it's kind of interesting and a bit complex as compared to image formation in a plane mirror. So both are different things. Okay, but the main thing is that for us to see different objects, reflection of light is important. It is only due to reflection that we get to see the different objects around us. Okay. So have you understood this concept, that how do we see objects around us? Hmm? Because light reflects off from the different surfaces and it enters into our eyes, right? Now getting it? So
Yes,
hope
sir.
that is clear. As in the beginning, as moments ago I was telling you that whenever light will fall on a surface, it might either go through reflection, refraction, or absorption. So talking about reflection, reflection will also be of different types. Huh? So say we have a very smooth surface. From a smooth surface, like a from a very smooth surface, regular reflection will be taking place. So if the surface of the given object is very smooth like this, thereby when light rays will be incident upon this, now when light rays will be incident upon this, so they are kind of falling like this. For example, it is coming in this direction and it makes up a certain angle. Say we have drawn a perpendicular line and we call this as normal. Okay, now say this is a
Sir, it is like
hmm,
angle of incidence.
not a, yeah, this one over here, this one is will be called as angle of incidence. Okay, now
Yeah.
represented with a small I. So that is your angle of incidence, and this one is your incident ray. That is called as incident ray. So the ray of light that is falling on the surface is called as incident ray. So it will be forming an angle with the normal line. Normal line is basically the imaginary line that we it's a 90-degree line drawn at an angle of 90-degree on the smooth surface. That is what a normal is. Okay. For convenience, let me erase this. So this light ray, once it falls on this, it will be reflected also. It will be reflected. So
Yeah.
that will be called as reflected ray of light. And the thing is
Or
that
the angle
when
of reflection.
angle of reflection, this will be angle of reflection. Okay. Now the thing is that whenever this will be happening on a very smooth surface, so thereby the angle of incidence and angle of reflection will be equal to each other. Meaning that if this is, let's just say 30 degree, so this will also be 30 degree. Getting it, Harima?
Yes.
So that is the case of a smooth reflection or regular reflection. Okay, now, and we get to see such a kind of reflection happening in the case of a mirror. The mirror has a very smooth and polished surface, huh? So thereby regular reflection will be taking place. But whenever the surface is not regular, it's irregular.
Irregular.
So right now, so thereby diffuse reflection or irregular reflection will be taking place, as you can see in this third diagram. Look at the
Yeah.
way how the light rays are incident upon it, and look at the way how light rays are reflected from it. They have reflected in different directions at different angles.
Sir, so light rays will be like passing, but the reflection will be a bit
So
like that, right?
the reflection will be taking place at different angles. It will be in random direction, not in a specific
Uh,
direction. Okay, no? Not at a specific angle.
yeah.
So that is what reflection is. Reflection is basically when light rays bounces off from a surface. Okay, na? So
Yes.
the way how reflection will happen will depend upon the type of surface. If the surface is very smooth, like this, like a mirror, so then the light ray, the incident ray will return back as the reflected ray at the same angle. Okay, so that will
Yes.
be case of regular reflection. But if the surface is irregular, so irregular reflection will be taking place.
Diffuse or irregular.
That is the thing. Answer this question.
Sir, for the diffuse reflection, I have one example.
Yes.
Sir, like there is a clear water, like
Hmm.
the water is still. So
Okay.
if I put a stone inside it, it will shake, right?
Repeat again what we're saying.
The water is still.
Hmm.
So if I put a stone, like if I throw a stone inside the water,
Mm-hmm.
the water will like be diffused, right?
No, that you're giving a different thing. Okay, the water will be kind of diffuse. Yes, I get understand that. Ripples will be formed on the water. Okay, no. Yes, we can take that one. That's one such example of that, or we
For
can take
an
example
irregular
of,
reflection.
yeah, or we can take, like in the case of water, reflection does not happen. Refraction happens there. Okay, no, Halima. There,
Yeah.
refraction happens, not reflection. Okay, only some amount of reflection happens. It's a very calm water, undisturbed water. So some amount of some reflection will also be happening, but majorly refraction happens. We should be learning in some time, in moment. Furthermore, talking about irregular surface, we can have example of desert, like where the sands would be present. So their surface would be kind of like this, would
Yeah.
be uneven. Hmm. When you walk on the road, the surface of the road will also not be very smooth. So that will also be irregular. Okay, answer the following question.
A smooth shining surface which rebounds the light back in same or a different direction is called uh, mirror, a lens reflection of light, point of incidence. Sir, rebound. Sir,
A very smooth and shiny surface
sir,
which
a mirror.
rebounds the light back. Exactly, that's a mirror, no? Very good. Answer
Maximum
this
part of
question.
light is reflected by maximum part of light. Uh, reflected. Sir, transparent.
See, you happen to have falling images, falling objects. Like say that you have a piece of marble over here. Okay, you have a piece of glass through which light can pass.
Pass.
Or in this, we have taken some water, or you have, let us say, taken some other thing. This, let us say, oil. Okay. So then in this, in the following objects that you see, this one can be taken as example of translucent object. The glass would be a
Transparent
transparent,
and opaque.
and the marble would be a opaque object. So out of the following, which one would be reflecting the light maximum? Maximum reflection of light will be taking place by, like
Uh,
translucent will allow some light to pass through it.
yeah. Sir,
Some of it
opaque.
will pass. Opaque, no,
No,
that
not
is the
opaque.
marble.
Sorry, transparent. Transparent.
You're not getting it. The question is maximum part of light is reflected. See, as the light rays will fall on this marble, it will be reflected back now.
Oh,
Understand this now. Like the glass being a transparent object will allow maximum amount of light to pass through it. Light is not bouncing back from the surface. While oil will allow, let's just say, 50% of the light rays to pass through it, 50% will be
yeah.
bounced back, let us say. 50% is bounced back, 50% is allowed to
And
pass.
for glass, it will be 100%.
Yes, 100% is passed.
And for opaque, I mean, for marble, it is 0%.
Right? So thereby it is reflecting most of the light, and that's why none of it is passing through. So that is opaque object. Okay.
Sir, I misunderstood the question.
Okay, okay, no worries. Then talking about the reflection, it would be incomplete if without discussing about the laws of reflection, right? So there are
Yes.
basically two laws of reflection. How many laws of reflection have been taught to you in the school?
Sir, two laws of
Two.
reflection.
Very good. So the first law of reflection says that angle of incidence is equal to angle of
S- Um, angle of sir,
angle of
angle of
reflection.
reflection is always equal to the angle of incidence.
Very good. So angle of incidence will always be equal to the angle of reflection or the other way, right? So that will happen when the condition applied is that
Um,
condition is that it should be happening on a smooth surface,
yes, smooth
right?
and shiny, sir,
Smooth and shiny
like a
surface,
mirror.
right? Like a plane mirror, as we have seen over here. So we have taken one example, a plane mirror. So over here, the light ray is falling upon it. So that is called as incident ray. By the way, you understand the terms like ray now. What is a ray in mathematics?
Yes,
Also, you'd have learned about this. Huh? Say, for example, you have a source of light like a torch. Okay, like a torch. So from this torch, the light would be coming off from this bulb, let us say,
sir,
right?
a ray like a laser light.
Hmm. Like a laser light also.
Yeah,
See, the important thing to understand over here is that, see,
sir, a
this is
ray
a
means
point,
one light, one light.
one, oh, yeah, one light, good. Okay, now, see, basically talking about ray now, in mathematics, we learn about ray that it has an origin, but a line that has an origin but has no end. That is what a ray is called. Hmm. When you learn
Yeah,
about line, a line has neither an end, neither a beginning, neither
neither
beginning,
a
neither
beginning.
end. That is what
Sir,
a
like
line is.
sir, like the Earth is round.
Yeah, right. So it has neither a beginning nor an end in terms of its circumference, right? Or
Yeah,
talking like if you were to take just one part of it, so then by it thereby then it is called as line segment.
line segment.
Good. Okay, we are concerned with ray. So ray has a source of origin but no end. Similarly, this light has a source of origin for from this torch now, right? But it does not have any end now where it will be ending. It doesn't have any end now.
Yeah,
Are you getting it? So the light
yes,
rays, whether it be from this torch, whether it be from the sun, from a star, etc. So it has a source of origin but does not have any end. So this will be called as light ray. That is how the term light ray came.
sir,
Understood
a
this
beam
now?
of light means the sunlight, sun's light.
Yeah, sun's light is one example of a beam of light. When you have multiple rays of light, that is called as beam. When you have multiple
Yeah.
rays of light, then it is called as beam of light. Okay, now that is the thing.
Yes.
So the first law says that this light ray is falling upon it. It is called as incident ray. And this normal, you should know that this is a imaginary line that we draw perpendicular to the plane mirror. You understand now what is perpendicular? Perpendicular क्या होता है? Have you learned about this? See this line that I am pointing over here, that is drawn at an angle of 90 degree to the surface of the plane mirror. Okay, that is what a normal is. Halima, you there? First of all, make yourself visible in the class. Let me know that you are there in the class.
Sir, I am.
Okay. So this light is falling upon it, and with the normal, it makes up an angle. That angle is called as angle of incidence. This I. And as it will be bouncing back from the plane surface, so thereby this bounced back ray of light is called as reflected ray, and the angle that it will be making with this perpendicular line with this normal will be called as angle of reflection. And in every circumstances they will be equal. The condition applied is that it should be a smooth surface. So that is the first law of reflection. Hope you have understood this. All right. Okay, is that much clear so far? Then the next law says that the next law is really important. The next law says that the incident ray, the incident ray, the reflected ray, the reflected ray, and the normal, and the normal at the point of incidence, all lie in the same plane. Now this one is really interesting. See, try to visualize this. In order to make you understand this, let us say that I have taken a plane surface. Okay, I have taken a plane surface, and let me take few pens. 1, 2, 3. Okay. Okay, see, try to visualize this. See, this is a plane surface. Okay. Now this is the incident ray. Okay. The one where I'm pointing. This one is the normal. This one is the reflected ray. This one is incident. This one is the reflected. This one is the normal. All of them are like on this. Let us say that this is the plane mirror. This is the surface of the plane mirror. It is like this over here. Okay. Now, if I were to tilt it like this, so we can get it. Say I am taking another plane over here. So the rule says that the second law of reflection says that the incident incident ray, the reflected ray, and the normal at the point of incidence. This point where this light ray is incident. 1 minute. See, this incident ray would be falling at a certain point, would be falling over here. So the rule says that the second law says that the incident ray, the normal, and the reflected ray, all of them lie in the same plane. Meaning that if I were to hold a paper behind this like this, now behind it like this, so all of them would be kind of appearing to be in the same plane. Halima, are you able to visualize this? Understand this? What I'm saying?
Yes, sir.
A little bit or getting it completely?
Sir, I got it.
Got it now? So basically, it's lying on the same plane like this over here. Let me hold it properly. So all of them would be lying on the same plane. It's like this. It's not like that this will be kind of like this or kind of like this. It will be exactly lying over this plane. And it's not like this would be like this. No, it would be kind of lying over this same plane. Okay. So that is what the second law of reflection says. The incident ray, this one, the normal ray, the normal and the reflected ray, all of them would be lying on the same plane.
On the
Okay, na?
same.
On the same plane. It's not like
Sir, there are only two laws of reflection, right?
only two laws of reflection, right? It's not like this one will be kind of like this, kind of like this, or this one will be like this. No, it's not like all of them would be distorted like this. No, all of them would be aligned at the same plane like this. Okay, now all of them would be aligned at the same plane like this. In this manner, I hope you can understand this.
Yes.
So that is what the two laws of reflection are. Okay, answer the question.
There are two laws of reflection. The angle of incident is always dashed to the angle of sir equal.
Equal. Very good. So that is something which we have learned. Okay, answer
The
this one.
angle between the reflected ray and the normal ray is called uh, uh, reflected ray and the normal.
Yeah.
Reflected. Sir, I got reflected ray and the normal. Sir, the angle of incidence.
No. This is your reflected ray. This is your normal,
Normal.
and this is your incident ray. Now answer
Incident.
this. Now answer it.
Oh, the between. Okay,
Mhm.
between the reflected ray and the reflected ray.
The angle between the normal, this line is normal, this one. The angle between the reflected ray and the normal is called as this R. Angle R. That is called as,
Ray.
this is called as angle of reflection now.
Oh,
Halima, remember as we learned about this, that angle of incidence is equal to the angle of reflection. So which angle were we talking about? We were talking about this angle now, this angle and this angle.
yes.
We were talking about these two angles now, that will be always equal to each other in magnitude, in their value. So that is what it says.
So the answer is angle of reflection.
Angle of reflection. Okay, answer the last
As
question.
the reflection of light from a smooth surface is called reflection of light from a
From a smooth surface.
smooth surface.
Have,
Uh,
have a look at this image. The
oh,
second image, yes,
regular reflection.
regular reflection. Very good. So that is regular reflection. And in the case of regular reflection, you get to see that they will be following the laws of reflection. They will adhere to the laws
Yes.
of reflection. Keep that in mind. While the diffuse reflection, they will not follow the laws of
They
reflection. Okay.
follow the laws of
Okay.
reflection.
Good. Answer the question.
Which of the following results in which of the following results in diffuse reflection? Plain mirror, shiny surface, silver, or diffuse reflection.
Hmm.
Um,
Diffused reflection means that irregular
sir,
reflection.
yes. So, sir, plain mirror.
Diffused reflection, it's an irregular reflection. For reference, a image has also been provided to you. No, I have taken a reference also. It's not following the laws of reflection. While a plane mirror follows the laws of reflection, it would be a wood now. Wood has a irregular surface, so wood will
Irregular
not be
surface.
following. Okay, because that is not important for you to understand. Okay, so the other thing which we are going to learn about in the class is The other things we should be learning in the class is about like if you were to raise your left hand in the mirror, if you were to
Sir,
raise your left hand in the mirror, it will appear as if you have raised on your
right hand.
right hand, right?
Sir,
So
that is
mhm,
called lateral inversion.
lateral inversion or left right inversion. Right now,
Yes.
we have certain application of that also. Like when we look at the
Sir,
letters of the word
sir,
ambulance.
uh, sir, like a mom. Like if we write a mom on the piece of paper,
Yeah.
like so on the mirror it will be like wow.
Yeah, like that. Okay. So
Sir,
if we were to
the
talk,
interchange of the left and right sides in the image of an object
mhm,
in a plane mirror is called the lateral.
lateral inversion, very good. Okay. So that is the case of lateral inversion, and there are several applications of this lateral inversion in our life also. Okay, now. So in the case of lateral inversion, what happens? The objects in the mirror would be kind of reversed. Reversed in which
Yes,
sense that the left will appear right, right will appear as if it is left. Okay, now.
yes.
So that will be observed.
Sir,
There
the
are
same
certain
thing will be in the ambulance also, right?
in the ambulance also.
In the
So
ambulance, it will be written the opposite, like the A will be in
exactly.
the left side. I mean the right side.
Mhm. So the
So when
letter
we
of
see
the word ambulance will be laterally inverted. It is intentionally written in this manner. Okay, na?
will yes,
Mhm. So it is laterally inverted. Why? So that
yes,
in order to convey the vehicle in front of them that it is an ambulance, like in the rear view mirror of the vehicle that is ahead of the mirror, it will appear, it will be spelled correctly. Like when you look at an ambulance now, say that this is an ambulance. Okay. So the letter on the ambulance would be spelled backwards like this. A, this M, B will be like this. I'm writing it over here. Okay. Now A, M, B would be like this. U would be like this.
yeah.
L like this. A
L
like this.
A
N would be
N.
like this, right? And C would be like this, and E will be like this, right? Okay.
So
So
everything will be like in the right hand side.
exactly like this. But so why is it so? So that if in the rear view mirror of the car now, the car that is ahead of it, this will be
Yeah.
spelled correctly. This will be spelled correctly, and it will be read as following. It will be read as
A
ambulance,
M. Yeah.
right? So the word ambulance is written in reverse because the mirror shows the characteristics of lateral inversion. Okay, now shows the characteristics of lateral inversion. So hope you are able to understand this thing right now.
Yes, sir.
So that the drivers of the vehicles in front of the ambulance can read correctly through their rear view mirror. So that is the reason it is done. So in order to understand this completely, we need to understand the properties of the image formed by a plane mirror. Okay, now a plane mirror. What are the properties of images that are formed by a plane mirror? So
Glasses.
talking about plane mirror first of all, just 1 minute. So the images that are
Sir,
formed
are
by a
you
plane mirror.
asking plane mirror uh, definition?
Yes.
Uh,
No, not the definition of plane mirror. Telling you. I'm going to tell you about the properties of images that are formed by a plane mirror. Okay, now. So see, the image that is formed by a plane mirror will always be equal to the size of the object. Getting it what I'm trying to say? Will be
yes.
equal to the size of the object. It will neither be smaller nor be bigger. So it forms images of same size as that of object. That is one of the property of image formed by plane mirror. Okay. It always forms an upright image, not an inverted image. Okay, now. Okay, have you ever seen yourself in the in a spoon, like on the back side of the spoon? If you have a
Sir,
new and
the
shiny spoon. Hmm.
front side of the spoon will be like like the upside down.
No, I'm saying now, like if you were to, if we look ourselves in the back portion of the spoon, on the back
Yeah.
side of the spoon. So,
Sometimes
mhm.
it will
Like,
be.
mhm.
Yeah.
I mean to say that when you look at the back surface of the spoon, I mean to say the front portion of the spoon, I mean to say. So thereby your image would be upside down, right?
Yeah.
But when you look at the back portion, it will be correct. Okay, now
Correct.
it will be correct, right? So you will see an upright image of yourself when you look at the back side of the spoon. But when you look
Sir,
at the inner
also the
side,
image will be erect.
yeah, image will be erect also. Good. So
The
talking about the
image is
plane,
laterally inverted also.
exactly that is also the case. Right now, talking about the plane mirror, the image is erect. It is erect. It is not inverted like this. So the person will be viewing himself or herself like this, not like this. Okay, now. So that is one of the property of this. Okay. Another thing, property of the plane mirror is that, see, if you want to see your full body image on a plane mirror, so you will require a mirror of at least half of your length. Say that if your height is, let us say, 5 feet. Say that your height is 5 feet, so you will at least require a mirror of 2.5 feet in length in order to view the full body image of yourself. So that is another property of a plane mirror, that in order to view the full body image, we need at least half the size of our body. We need mirror half the size of our body. Okay, Halima?
Yes, sir.
Okay. Okay, so Halima, let's do one thing. Leave the class over here. We'll be continuing from the next class. Okay, now? Okay, then Allah Hafiz.
Okay, sir. Allah